Yo, what's up, guys? So, this world might be a little bit busy already because, I don't know, I've been messing around in it. But I just want to go over what I've done so far. Because, I don't know anything about redstone, and it's kind of crazy. I don't know. This stuff is really freaking complicated. I wasn't expecting it. I mean, I've always watched YouTube channels. They're like, "Oh, dude, it's actually pretty simple." It's like since I'm going into computer science, I figured it'd be pretty cool to kind of brute force myself to figure out how it works. So yeah, that's that. All I know is some of the basic computer logic. I've been taking a PLC class, so I know a little bit about how it works. The NOT's pretty easy. It inverts your signal that you put in. I mean, you can accomplish this with this little redstone torch. I don't know why this is done how that is, but I guess that's just how Minecraft does that. You kind of click it, and then I don't know, it kind of just goes the other way. So like this, you can see like some redstone dust coming off. I'm pretty sure I'm like the last person to figure that out on Earth, but that means that it's on. So it's like yeah, I don't know. This ore block. I mean, you don't really need anything. It's just an ore. This thing will be on no matter which one is on. You can try each combination. If they're both on, nothing changes, or it's only off if both of them are off. This NOR is the opposite of that. So you take that and then you invert the output. So we combine a OR and a NOT right here. So we invert the output like this using this little torch, and we take the kind of same input as the OR here. So we combine it to make a NOR, not OR. So now this thing is only on whenever they're both off. So if they're both on, nothing. If this one's on and the other one, nothing. Same thing this other way, yeah. So they both have to be off to make this NOR. That's pretty cool. Then we got AND. I found it easier to make the NAND first than the AND. Basically, the AND here, these things both have to be flicked in order for this thing to go on. So what I mean by that is like this thing could be on, off, this thing could be on, off. It's kind of like a not NOR, you know what I mean? I invert the NOR output, but on the other end, on the inputs. I invert the inputs and then feed it into the NOT. That's how the AND works. So they both have to be on in order for this thing to be on. It's pretty basic. It makes sense. And then finally, the NAND is the opposite of that. So you don't really need this invert right here. All you need to do is invert the inputs here. So bada bing, bada boom. It's only off whenever both of them are on. It's just the same output as this, but all the inputs are flip-flopped. Now we got a special thing over here that took me a little bit longer. I will have to admit I did look it up. I looked up how to do it because I was like, what the heck? How do you make an XOR gate? I'm pretty sure you can make an XOR gate using a bunch of other smaller logic. I should be able to show it on screen here. I'm using a thing called a Digital Logic Simulator. It's made by that one Sebastian something guy. I don't know. This guy's awesome. This XOR gate, basically it's like the OR, but if here they're both on right now, so I'll turn it off. Basically, if you turn this one on, then it turns on. It's like an OR, but if both of them are on, it's also off. If both of these switches are toggled, it's off. So it only works if only one of these is on or off. If they are basically the same state, it's off. Anything else, it's on. And then the XNOR is fun saying that. It's just the inverted output. So this light is only on whenever both of these things are the same value. And that's using these things called comparators. I don't know how these things work because I mean I'm new to Redstone. I mean I've been playing this game for years, kind of on and off, but I never really dabbled in Redstone. I mean I'd love to get like a little simple guide, but I'm pretty lazy. I don't really want to do that. I know that you can make like a cool little, or wait, it was something like this. You make a cool little loop here by doing this. I think you have to. So with that knowledge, I decided to make a little bit of a computer, or the basics of a computer edition kind of software. I really like computer logic, so it's cool to do in Minecraft. So using all this logic that I figured out, well, kind of figured out, except for this, I made my first adder. So this thing is really cool. It's a bunch of different things. I mean, if I look at it from here, it kind of lines up with my diagram in Digital Logic Sim. But basically, what it does is it adds 2 bits together and it carries a bit, kind of like stacking addition. So let's just, instead of thinking of like how they are the signs, just say like, okay, these are like numbers. So 1 plus 0, that's 1. 1 is over here noted as this, the sum bit, and also the carry out bit. So 1 plus 0 is obviously 1. But if you want to add 1 plus 1, you get 2, and that moves it over to the carry bit. This is 2, or 0 and then a 1 to the to the bit to the left of it. That's pretty cool. And then if you're overflowing, you go to carry, and then you get both. You get 1 and 1. And the next one over is the carry bit. I probably should have swapped these two actually, but it's okay, it's fine. Basically, it's like a single adder. It adds 2 single bit digits, and it carries over for continued adding. So I took this little function, I guess I can call it a function here. It's very big, and I had to learn how to clone and fill and all that crap in Java. I never tampered with any of that. So I copied all this and I moved it over and I made a 4-bit adder, my first version of one. So what this does is it's at 4 adders in a row, 4 bits, 4-bit adder. It basically sequences each like output into the next input, and then it brings them all back to become one big adder over here. I don't know, it's kind of hard to explain. It made more sense when I was building it, and it took like forever. Man, it took forever. So we got all these things going into each other. I mean, we got all the carry bits. This last carry bit still serves as the carry bit to the 4-bit adder. I mean, I think I could probably find a way to chain up 2 of these next to each other, and then I can make an 8-bit adder, which is more useful. I don't want, it's not really that cool having 4 bits to work with. All right. So this is the output at the top here, and these are the 2 little numbers you can add together. And since this isn't binary, we don't have anything where it's like ones place, tens place, hundreds place, thousands place, where each thing is an order of magnitude above that. Since we're using binary, we have base 2 instead of base 10. So the ones place is 1, obviously. The next place, the tens place for binary, is just that times itself 2 instead of 10. And then the next place over, and next order of magnitude is 4, and then 8. And then you keep going 16, 32, 64, 120, all that stuff. But so if you want to add these numbers, you kind of have to treat it like these are their own addition things. So I can add 1 and 1, and that should give me 2. 1 plus 1 is 2. Oh my gosh, mind blower. But if I want to make the number 3 here, if I want to add 3 and 1, I say 1 plus 2 in this row. 1 plus 2 is 3. This bit would be the number 3 in decimal in our like base 10 notations. So if you wrote this bit out, it would be 0011. So a string of 0011 is equal to 3 in decimal notation. But obviously we omit the leading zeros here because those don't matter. We all know there's infinite zeros to the left of every number. 3 plus 1 is 4. Let's just say we want to add on 3 and 3. So that'll get us 6. So 4 plus 2 is 6 at the output there. So we want to say what? Let's do 1 and 2 and 4. That's 7. 7 plus 3 is 10. So we get 8 and 2 here. So yeah, the number 10 here is 1010. Kind of looks like the decimal 10, but it's just a coincidence. Yeah, and if we want to overflow it a little bit by turning all the knobs, everything should light up except for this, yeah, the carry bit here. So we want to turn on this last carry bit to fill all the lights up. Isn't that neat? Anyway, yeah, so this is a simple little addition mechanism, and that's almost as far as I've gotten. I made this thing, and that was when I had the idea to start recording my progress, because I was like, yo, I made a freaking adder in Minecraft. This just took me like 2 days to do all this crap. And the most time I spent on it was trying to figure out how to copy and paste this using the clone command without having it all be like random. These are all equally distant apart from each other. And that's just for my comfort there. It sort of doesn't really matter that much, but I should have stacked them on top of each other. I think I should have stacked them because if I had stacked them, it would have been a lot more compact. It would have been a lot cooler. The hardest part about making all this actually, or I guess second hardest because I already said the hardest, was lining all these stupid lines up. I think it's like 14 blocks of this redstone like extends before it goes away. But like having it all lined up is really annoying. There's got to be a faster way to do it or a way to like carry redstone signals without wasting a tick. It takes a little bit for the signal to get back, You can kind of see it. You can see it traveling there. You see that? Next one. You see it traveling to the signal here, or to the output here, and that's not cool. So to fix that, I should probably in my next iteration, my V2, probably want to stack them on top of each other so they don't have to travel as far. And that leads me to my adder V2. I should actually make this my V1 first. But this is my second iteration of my adder. So basically all I did was I went through like a kabillion migraines trying to figure out how to take this and condense it. Like the more condensed I can make this, the faster the output is over here. But I'm not sure if I did that good of a job. I wanted this to only be 3 tiles tall, but I ended up making it 5 because I realized that if I was going to go for my original design like I did over there, I would need this top branch to reach over. I think if I swapped both the ands, like the outputs of the ands over here, like make this yellow over here, make the blue over here, then it would be not as, it wouldn't take as long, but I don't know. I got my 2 XORs. This is my big problem. I hate these XORs. They have to be the exact same outputs once they hit the sides of these comparators. All I know about the comparator is that it sends a different output depending on what signal is fed into the side of it. I think that only is true whenever these lights are toggled on. I don't know. But basically, it has to be 1, 2, 3, 4 until it reaches that, and then 1, 2, 3, 4 until it reaches this side. And I have to make sure these are equally distant, because if this one's like a little bit earlier and there's 1, 2, 3, 4, 5 and then 1, 2, 3, 4, I think there's a way to like break it that way. I don't know. I also just learned about target blocks, where like little target blocks can move the freaking like redstone signals. Like it doesn't extend over to the next thing. And I was like, what the crap? Because holy crap, man, I wish I knew that before I made this. I could probably make this way smaller now. I could probably make this 3 blocks tall now because of the target blocks. I don't know. These things are kind of awesome, I think. I could like use a target block to, I don't know. Anyway, so I guess I should test it. I kind of extended the outputs to go a little bit further since this thing is so tall now. But, so yeah, it's the same thing. It adds 1 bit and another bit that brings the carry bit. You overflow it, both of them are on. And it works for any combination. I had to test it manually every combination because I wasn't confident in my ability to do this. Anyway, now that it is done, I'm going to start stacking these things to see if I can make a V2 adder. I mean, it probably won't be that much faster, but it will be a lot more compact here, and that's a lot cooler, I think. If I can connect it all up, it'll be tiny, teensy tiny, in comparison to this gigantic freaking contraption. Anyway, that's all I got for today. Thank you guys.